like to go ahead and take any questions that you may have. Yes.
Hi, David Lawrence, Johns Hopkins APL. Kevin, this is for you. Noticed a lot of interesting topics for physical sciences measurements. Is there a process to feed in, like if people have new ideas, new measurements, new fields that could feed into what you're doing?
Yeah, it would be really communicating with our program scientist, Brad Bailey, and program manager, Hans Hansen, and just setting up meetings and talking with them. Here's some ideas, here's some thoughts. We do that all the time to bring information in if it's coming in. Going out, we do have the American Society for Gravitational Space Research. Our meeting is going to be in November, the 15th, the 16th, 17th, and 18th, and that's where we communicate out, similar to what you have for League. That's where we communicate out and in to our science communities. So there's always good dialogue that can be had from direct communication.
Okay, thank you.
Sure. Next question.
Excuse me. Yes, this is for the space weathering, the heliophysics. I think we use the term space weather within the lunar science community a little different. Namely, we use it as a verb rather than a ongoing process. When we look at lunar soils, we always have to ask the question, how long have they been exposed to the kind of environment that you've been describing? My question to you is, how far back from where we are now can you take a description of the space weather? Can you go back 100 million years, a billion years? How far can you extend the understanding of space weather as you have it, that we have to integrate in the soils on the moon?
Yeah, so definitely a good point on space weather versus space weathering.
Yeah.
That ing makes a big difference, right? So yeah, to answer the question, I'll say I'm not the expert in that particular field, though it is one of those objectives in the Moon to Mars strategy and architecture. The way I understand it, I think we don't know exactly how far back we can actually know for sure. So that's one of the open questions about how much does the regolith actually eventually tell us, almost like rings on a tree, about the life cycle of the sun over these, tens of millions, hundreds of, who knows, like quite how far back we may go to have valid answers there. But if you want to know more, follow up with an email and I'll make sure we get you connected with the right expert in that particular subject.
Very good.
Yeah, I think we have enough for maybe two quick questions, one online.
Peter Chi has a question for Brent Gary and NASA in general. Because CLIPS has also enabled payload opportunities for many countries that are interested in science on the lunar surface, is there any NASA program that can support US activity in collaboration with international teams that purchase CLIPS payloads?
So good question. So we are working with some of the international partners, so that we are some of the payload deliveries do have international instrumentation, and we have in the CLIPS organization, we do have a CLIPS, I guess, international liaison that kind of works with the international community to facilitate those different payloads from other countries to go on these NASA deliveries. So there are places in STEP, but I don't know if it's like an actual, but it's, yes.
Hi, thank you so much. I'm Artash. My question is to James, and it's in regard to the power generation and space weather on the moon. So I'm not sure whether there's like the solar power or nuclear power, for example, would be the primary source of energy generation on the moon. But how could flares from the sun, like on Earth, we have the atmosphere to protect us, but how could these flares potentially impact the energy generation system? Like I assume on the dark side of the moon, there's obviously no potential for solar energy. So assuming nuclear energy, for example. So would these solar flares harm energy generation, and would they be able to reach the far side of the moon in that way?
So I'll start by answering the prior question real quick. So another international opportunity is actually Gateway. Those payloads, very similar to ISS, will have international opportunities as well. So then to jump over to the potential impacts of the sun harmful on energy on the moon. It's actually the analogy is here on Earth as well. Our power systems are very vulnerable to these big solar events, even through the magnetosphere. That protection is lost on the moon. So those same resources on the surface, whether it's solar or any other hardware, are very susceptible to those high energy particles and the power surges potentially on those environments and the hardware. On the backside of the moon, I don't know that I've recently read to remember exactly, but the particles are very much potentially present, and depending on where you are in the orbit, could be impacting those things. I know even interesting, some of the folks at the university are like, well, does it matter if you're at the poles compared to the equator? And like, what are those potential impacts even in that kind of way? So hopefully that is some helpful answer, but we can talk more.
All right, that's it. And I'd like to thank everyone for attending. Thank you, and also for our speakers. Thank you.